Hi everybody, Chris AMS, hope you're all well. Today I'm looking at a Fiat 500, 2017 model year. It has got the 1.2 8-valve fire engine in it. Customer says no start, no crank kind of thing. Went to the shops, come back out, didn't start. Okay. I've given the vehicle a code scan and there are no faults in the engine management system. If you remember from one of the previous videos I did, I had a no start condition where the clutch pedal was an issue. We can look on here at clutch pedal, go on to the data list, using the old Zeus, old snap on, and we've got clutch pedal. Now I've got, at the moment for testing purposes, I've got my torque wrench holding the clutch pedal down, and what you see, it's showing us the clutch pedal pressed. So it's not been inhibited from starting because of a clutch pedal issue. It's not clicking, it's not doing anything really, kind of thing. I think my first port of call for testing is I'm going to go to the starter relay, which is located under the bonnet. Reason for this is if it was an immobilizer issue or anything like that that was preventing starting, then we'd get no start signal from at the relay, kind of thing. No signal saying yes, you can crank over, kind of thing. And we can check to see whether we're getting all the correct power supplies and grounds and stuff at starter, and actually test the starter from that point as well. So let me do that. So I apologise for the wind. I need to get one of those microphones that stop all the wind noise and stuff, because I think it's pretty windy out here today. So looking at my technical data system, it shows me the layout of the fuse box. R9, which is located there, is listed as a starter inhibitor relay. Look at our fuse box, and our starter inhibitor relay is this one. So I'm going to pull the relay. If I can, it's a bit awkward to get your fingers to. There's the relay. Now on the side of the relay, if we look at the relay, well, we can see that kind of thing. We've got a little diagram of the relay in the bottom corner, makes our life easy. So pins 5 and 3 are the power supply. So that's what powers the starter motor. And the two on the left there, pins 1 and 2, they are the control side of the relay. So that's what the engine management system will tell the relay to activate. So we look on the bottom. If you take my word for it, pins 3 and 5 is one's that one, and the other one is this one here. So these two top two here are the ones that control the actual circuit. So next step, I've got my Power Probe 3, I think, is it? Power Probe 3? Yeah, Power Probe 3 out. Okay, but what I'm actually going to do is I'm going to take that out, and I'm going to use one of the probe cables out of my scope. I think plug in the end of there with that on the end. Simple reason being, it makes it just a bit of easier of access, kind of thing. So we're going to go into there. So I've gone into that side of the relay and I've got a permanent ground. Okay, so hence the green light, 0 volts. I've got a ground. Okay, that is likely to be going to, that's the terminal that's going to the starter motor, to the signal, the exciter wire of the starter motor. This side, I've got nothing. Okay, and then on our, so these two here, if you can see this one and this one, these activate the relay or close the switch on the relay in order to send power out. So here I've got 8.1 volts. That's what I call a bias voltage. So that'll be testing the signal to the relay, and then I've got ground on this side. Okay. So what's likely to happen is this terminal here will power up, will be powered by the ECU or the fuse box, depending on without looking at the wired diagram, difficult to tell. That will then close the switch between these two and allow power to flow from this terminal down this terminal and to the starter motor. So obviously this terminal at the moment has no voltage, but I reckon if we have a look, I'm going to put this up there like that so we can see it from where the key is. So basically, if we look at that, I'm going to turn the key to crank position, and there you go. You can see we've got battery voltage and the red light is illuminated. And then we are going to go to, what did we say, the exciter. So there we've got our 8.1 volts. So that's the signal wire to tell the relay to activate. I'll put that back up there, like so. Come on, stay, get. We've got 8.1s. So we're going to go to cranking. And there we go, you can see that. So, based off that test, I can see that the immobiliser system isn't affecting starting or cranking. That the yeah, but I haven't tested the relay yet, kind of thing. I'm going to assume the relay's working at the moment, kind of thing. My next step in testing, I think, would be to actually see if I can get the starter motor to activate from here, from the relay. So let's plug the other terminal. I'm going to use this on the end of my current clamp. Reason is it uses more current. Well, I don't want to burn out the wiring or anything like that kind of thing. So if I get in the right one, so if you look at my terminal there, I've plugged into the wire that goes down to the starter. Be very careful when you're doing tests like this on any kind of fuse box. Unless you know exactly what you're doing, you could blow something up, and you don't want to do that. So I know what I'm doing. So I'm going to put a power supply into this terminal which goes down to the starter. Now I should see the engine crank. There's power in. Now cranking. Now this would potentially give us an indication that our starter motor is faulty. That's not the be-all end-all of the testing kind of thing. I would now go down to the starter motor and test it at the starter motor. But one other test that we can do whilst we're up at this end is I'm going to replace the relay. Now, one of the things the customer has told me is it's had a clutch fitted a couple of 3 days ago, I think, or a couple of 3 days before the breakdown. So we're going to have a look. So one other thing I can test while I'm up here is I'm going to use my incandescent test probe. I've got that connected to earth here. Let's get rid of all this other crud out of the way. Again, with any testing, you want to make sure that your test probe works. So that's lit up, see that there? Now, with that connected to ground, and this connected to a ground on the vehicle, so there's actually a ground point here on top of a little one on top of the air conditioning pump, and I am going to clip that onto there. Okay, now for the starter circuit to work, it has a permanent power supply from the battery to the starter, and then it has an exciter wire that when you turn the key to the cranking position, it sends a signal down to engage the solenoid. To complete the circuit though, the starter motor needs to be grounded. It needs to be earthed back to the battery. So what we're doing here is with our incandescent test probe plugged in there kind of thing, I am going to crank the vehicle. So I'm going to put it under a load. Now if you can see that there, when I crank the vehicle, the power probe illuminates. Now what does that mean? That means that the power supply or the voltage or the current is not getting out through the ground on the engine. There'll be a big earth trap somewhere in the engine, and it is actually escaping back to the battery through our test light, and that's why it illuminates. Now if we had a good ground, that test light should not illuminate. So what I'm going to do next is I'm going to go hunting I believe on top of the gearbox underneath the battery, so I might have to take all this out. There should be the big engine earth, so it bolts to the top of the gearbox kind of thing and earths the engine and all that stuff out kind of thing. So we'll have a look and we'll see what kind of condition that's in. Right, so I've gained access to the cable. I've took the battery out. I had to unplug the ECU and unbolted the under tray. Now if I lift this up, and I've also disconnected to gain access to clutch slave cylinder, which is that little black doodad there kind of thing. Now the bit that we're interested in, and I said about the engine and the gearbox being grounded, is this thing here. All right, that's the cable, earth cable to the engine and gearbox. Now if you watch that, you can see that's a loosey goosey. Now that lifts up and down and twists around. That is enough to give a bad ground to an engine and prevent it from starting. Now, as I said before, it has had a clutch on it before. I'm going to tighten that up and then put it back together and see if it starts kind of thing. I'm hoping that will be good, although see it's one of these braided cable styles kind of thing. They're never a good idea, the way they do these braided earth straps. They corrode out, and it's not as good as copper. So I'm going to tighten that up, and then what we'll do then is we'll have another look and we'll see what we got going on. Cool. Right, so we're back together. Battery's back in. I've tightened the terminal for the earth strap to the top of the gearbox. We've got our incandescent test light plugged in, clutch pedals down. Now it should start, so let's have a look quickly first if it will start. Tickety boo, that's what we want to see. The engine's starting at the first time. Now what we're going to do is look closely at our test light when we crank it. And if you notice that the test light did not illuminate, which means no current is running through that, or not enough current is running through that, because it's running through the earth strap back to the battery the way it was designed to. So happy fix. Unfortunately, it was down to poor fitment or poor replacement of the clutch that this had a few days ago or a week ago. And they just left the bolt loose. Sometimes it happens, but there are other bits and pieces on it that don't show necessarily the greatest workmanship kind of thing. But yes, anyway, we've got it back running kind of thing. I hope you enjoyed the video. Please give it a like or a share or whatever, and have a look at some of the other videos on YouTube. So give the Facebook page and stuff a like. I'll endeavour to get a microphone that stops the wind noise and stuff for next time. But yeah, have a good day. Take care.